Right, so we are on to our last part, which is, we are going to look at this one. You see that tangent minus to the power tangent minus 1 2x is it's 2x minus 8 over 3x cubed. So you figure this out in the front part of the question, and then they ask hence deduce this, all right, which is a square root 1 plus tangent inverse 2x. So sometimes it's just outright series within the series. Okay, so this is not a standard series. You realize that you don't have tangent inverse in your standard series expansion within your formula. Okay, so the thing is, it still makes sense here because in the front part of the question they ask you to figure this out. So now they give you another expression or function, okay, square root 1 plus tangent inverse 2x, and in this case you would have to use this, all right, to expand this. This is actually in fact a series within a series, like I said. So what we'll do with this is that we will write 1, okay, plus, now we're going to replace the tangent inverse 2x with this thing over here, which is 2x minus 8 over 3x cubed plus ... All right, just like the one in number 3 that we've written over here where we talk about the trigonometry, right? The later part of the solving actually is a series within a series, like what we did, like what we are going to do over here. Okay, so in fact, yeah, come to think of it, I should have actually shown this before the trigo ones, then it makes more sense, the kind of flow. But well, okay, so nonetheless, we are here. So let's go ahead and do that. Okay, we're gonna use the series, okay, that we have from our standard, that we have from our MF26. Okay, let's write that down again. It will be 1 plus x to the power n is equals to 1 plus nx plus n bracket n minus 1 2 factorial x squared plus ... Okay, so we are going to treat our x, okay, over here as these, okay, and then our n happens to be half in this case. So let's go ahead and expand this. Okay, so we have 1 plus half, okay, x will be 2x minus 8 over 3x cubed plus ... and then we can go one more, okay, so plus, right, so half, and then times half minus 1 is minus half, over 2 factorial x squared, which is 2x minus 8 over 3x cubed plus ... Okay, so, and we have a square here too. Okay, and then we're going to do one more, all right? We're going to do one more, which is plus, okay, half minus half. Okay, then we have minus half minus 1, which will give us minus 1.5 over 3 factorial. Okay, I'm running out of space here, so I'm going to like just do an insert. So 2x minus 8 over 3x cubed plus ... cube. Okay, then after that plus ... All right. Now the question wants us to evaluate this, or rather deduce this up to and including x cubed. So we need to include this one, which will give us also a cube term. Okay, so let's continue. Okay, we're going to expand this and simplify it. So 1 plus half times 2 is just x, minus we have 4 over 3 x cubed, okay, and then for this guy, all right, it's half times minus half, which gives us minus 1/4. Minus 1/4 divided by 2 factorial gives us minus 1/8. So we have minus 1 over 8 bracket. Okay, now we're going to evaluate this. So just imagine that, you know, you drop the 2 over here and then you bring you put the second bracket over here. So we got a bracket times another bracket. So they are the same. So we have a 2x and we were going to do the rainbow, right? So 2x times 2x, that's going to give us 4x squared. And then after that, 2x times the second term, which happens to be this guy. Oops. Okay. And that will give us the x to the power 4, which we do not need. So in that case, we can ignore that. And then as we move on to this guy, minus 8 over 3x cubed. When it multiplies to the first guy over here, which happens to be 2x, then again we're going to get x to the power of 4. So we can just go ahead and ignore them. All right. Now we're going to move on to this one. Okay. So for this one, we got half times minus half times this. So you know what? I'm just going to press my calculator for that. Okay. So let's go figure that out. So we have half times minus half times minus 1.5, which is 3 over 2, over 3 factorial, okay? So it's 1 over 16, okay? So this guy is 1 over 16. So, okay, let's write that here. And then we're going to expand this, which is cube, okay? So again, we can use our rainbow method. You can do a little bit of imagination. We have 3 brackets side by side, okay? So the 2x will, when we expand it, we'll have the 2x multiplied by the 2x multiplied by the 2x in the third bracket. So in total, we will have 2x holding cube. That gives us 8x cubed, okay? We want this term because that's the cube term. So after that, as you expand the rest, you realize that they have higher powers, okay? So we don't need them, okay? So plus dot dot dot, all right? So if you find that difficult, just go ahead and write them out in the brackets form like this, okay, on a piece of rough paper, and then you know write them out in full, okay? I'm not going to do that here, and then you will see that as you expand them, it's quite easy for you to see that this is the only term you want in the expansion, and the rest are not required, okay? So let's get back here, and then we are almost to the end. So we have 1 plus x minus, over here, this one, let's do the x squared term first. So this is 4 over 8, which happens to be half x squared. And then we have minus 4 over 3 plus half, okay? So, which is 8 over 16, okay? So minus 4 over 3, and then 8 over 16, which is half, so plus half. And we have minus 5 over 6, minus 5 over 6x cubed, plus dot dot dot. Okay, so there you have it. So that's how we solve this question. Now, as I've mentioned at the start of the lesson, remember to familiarize yourself with all these 5 different variants or techniques. Okay, so in future, when you come across a question that asks you to deduce the expression of a new series from a given series, okay, you can just look at this checklist, okay, of 5 and see which one applies the best, all right? Now, hopefully during exams, you will be able to identify the correct one and solve the question and get full marks for this part here, okay?